During World War II, the world ran out of almost everything: steel, rubber, fuel, even protection itself. But when the factories went silent and resources vanished, innovation didn't stop. It changed shape. And in the middle of that chaos, someone discovered a way to make paint. Bullet-resistant. Not armor, not metal, just paint. And it worked. This is the forgotten story of how Allied scientists turned ordinary wood into a battlefield shield, using chemistry, desperation, and a brush. By 1942, the world was deep in total war. Every scrap of steel went to tanks, warships, and aircraft. On the front lines, soldiers had to fight and survive with whatever materials were left behind. Wooden crates became walls. Trucks were made from timber. And when bullets hit, that wood exploded into deadly splinters. Field engineers faced an impossible question. How do you protect men and machines when you have no armor left to use? The answer, surprisingly, would come not from a weapons lab, but from a wood lab. At the U.S. Forest Products Laboratory in Madison, Wisconsin, scientists weren't building bombs. They were studying wood. Their mission? Find ways to make wooden structures tougher for the war effort. What they discovered changed everything. By mixing a simple chemical called sodium silicate, also known as water glass, with organic binders like casein, a milk protein, they found they could harden wood. When applied like paint, this compound seeped into the wood grain and reacted with carbon dioxide in the air. What formed was a thin, invisible armor, a silica crust that made the surface dense, hard, and resistant to heat, water, and, yes, even bullets. Sodium silicate is a fascinating substance, a mineral dissolved in water that dries into glass-like crystals. When brushed onto wood, it doesn't just sit on top. It fills the pores, bonding with the cellulose fibers inside. Once dry, it leaves behind a microscopic ceramic network. Light, cheap, and incredibly strong. Soldiers in the field began calling it liquid armor paint. It was never an official term, but it fit perfectly, because with every coat, ordinary wood transformed into something almost unrecognizable. Boards treated with multiple layers could actually deflect small-caliber rounds, especially 9mm and 45 ACP. Even when bullets broke through, the wood didn't splinter. It just dented and stayed solid. Field engineers began experimenting. In North Africa, where supplies were scarce, British and American troops mixed sodium silicate with their leftover paint and varnish. They brushed it onto guard posts, ammunition boxes, and truck panels. After several coats and a few hours of drying in the desert sun, the wood felt different, harder, heavier, almost like stone. Tests in the field confirmed it. Bullet penetration was dramatically reduced. It wasn't going to stop a machine gun burst, but it could absorb hits that would normally shatter a crate or pierce a wall. And, for soldiers in the open, that meant the difference between life and death. By now, the chemistry was spreading through Allied engineering manuals under technical terms like silicate-treated coatings. But for those who used it, it wasn't chemistry. It was survival. In the jungles of Burma, engineers coated the undersides of wooden trucks carrying ammunition. In the Pacific, naval carpenters applied it to small boats and pontoon bridges to reduce splintering from shrapnel. And in Europe, it was even tested on wooden bunkers and observation posts. It turned soft pine into something resembling composite armor, decades before composites became standard. The beauty of this formula was how simple it was. No factory, no machines, just a bucket, a brush, and time. Soldiers mixed 1 part sodium silicate with 1 part oil-based paint or varnish, stirred it until smooth, and applied it directly to sanded wood. Once it dried, They added another coat, and another. Each layer fused deeper into the surface, sealing every pore with hardened minerals. Some engineers even warmed the wood gently after painting, using sunlight, stoves, or exhaust heat to help the compound cure deeper. After several coats, a wooden panel felt cold, dense, and almost metallic to the touch. It was, in every sense, a liquid-made armor. Reports from testing units were impressive. 5 coats of silicate paint could resist low-velocity 9mm rounds and reduce splintering by more than 60%. In addition to strength, the coating added fire resistance. Wood treated with silicate didn't ignite easily. It charred but refused to burn. And it also resisted rot, insects, and tropical humidity. So one compound solved 3 problems: protection from bullets, resistance to fire, and long-term durability in harsh climates. To soldiers who had no armor plates, that was nothing short of miraculous. Despite its success, the formula never became standard issue. It was too improvised, too localized, something passed around through field reports and engineers' notes rather than official production lines. But its influence quietly lived on. The idea of chemically reinforcing wood without melting or laminating it inspired post-war research into modern composites, resins, and fiber-reinforced panels. In a way, this forgotten wartime hack helped pave the path toward the advanced materials we use today, from fireproof coatings to ballistic fiberglass. And here's the fascinating part. This wasn't a lost technology. You can still buy sodium silicate today at any hardware store, often labeled as water glass or silicate sealer. By mixing it with clear varnish or outdoor wood finish, anyone can recreate the WWII formula. The process is the same. Apply multiple coats, let it dry completely between layers, and watch the surface become more durable, fire-resistant, and water-sealed. Survivalists, restorers, and builders still use it today to reinforce sheds, cabins, and toolboxes, proof that an invention born from desperation can still serve in peace. The bulletproof paint might sound like a myth, but it's very real. And it captures the true spirit of wartime engineering. During the war, scientists weren't sitting in perfect laboratories waiting for ideal conditions. They worked with what they had: wood, paint, chemicals, and the determination to protect lives. When steel ran out, they didn't give up. They turned to chemistry. They turned to creativity. And they found armor in the unlikeliest of places, inside a tin of paint. There's something deeply human about that. When resources vanish, the mind sharpens. When survival depends on ingenuity, even the simplest materials become extraordinary. The story of bulletproof paint isn't just about a scientific trick. It's about what people are capable of when necessity pushes them to think differently. Because sometimes, the greatest inventions aren't born from abundance, but from desperation. If stories like this fascinate you, the forgotten technologies, the small inventions that shaped the outcome of war, then you're in the right place. Subscribe, share this video with a fellow history enthusiast, and help keep these stories alive. Because understanding history isn't just about what we invented, it's about why we needed to.